and we have hyperbola. Hyperbola. Cool. Now, the fantastic way of identification is when you write, maybe in a standard or non-standard form, the equation, and then let's see we have x squared plus y squared. In front, different numbers, no? Pero it's not important. You see que no variable es missing, pero square es aromática, elixir o circle, no? Circle es cuando this number is the same. Parábola, no. Parábola is x squared and y, or y squared and x. Now remember, we have two kinds of parabola. This is the vertical, and this is horizontal. Correct. I have only one branch, no, of the parabola, no, not two. And this is horizontal. Okay, the clue is when you have one square, another non-square, it's parabola. Okay, and hyperbola, you have always the same situation. We have both a square, but in between this is no plus, it's minus. It's minus. Okay, hyperbola. Okay, we studied today. But no, we are painting the first example of the parabola, no? Okay, it's example 4. I call example 4. Example 4 is, let's see. Is 4 x squared minus 20 x minus ay plus 57 equal to 0. Okay, I recognize que es de parábola, of course, because x is squared, y no squared, and the term x and y along linear represent the translation, the transformation, and the motion of the center. This is totally, well, not irrelevant, pero es in the first side, you see x squared and y not squared, it's parabola. What kind? Vertical. Parabola. So, right? So now I need to manipulate this equation in order to express it 3D. Express it like this equation. No, suppose in the equation we have x squared, no, x minus h squared is equal to 4b y minus k. I need to manipulate this equation in order to express this case. Okay, let's do it. So now for doing this job, we grouping somehow the x part. You copy, I see by coincidence, in this case no always happen, but in this case happen. The greatest common factor is 4. So we have x squared minus 5. X plus, and you complete the square of this trinomial of the x using this imaginary number. Okay, and so now my goal is that part look like this part when I complete the square. So the rest is equal sign. You move everything that contains y to the other side. So it's a positive ay minus 57 plus a box. And by the way, this box is a similar box or similar, no, depending on this. No? And now remember the formula. The formula is b divided by a, b divided by 2. Sorry. A square. In this case, unfortunately, BFI. Remember, I don't care the sign. The sign is not important. You take 5 divided by 2 and a square. It's odd number versus decimal, no? That is okay. It's a 25 over 4, no? Because 5 squared is 25, 2 squared 4. And this is the number I put inside this box, 25 over 4. Over 4. And I did this action. Obviously, this trinomial now is perfect square. Now, in the right-hand side, you put another number. Okay, in this case, is just 25, no 4, because this 4 mentally in my mind is cancelled out with this. Okay, the action that you put inside the parenthesis 25 over 4 actually is only put additional artificially new 25 and the left hand side. In order to keep the equilibrium, when you put 25 and the right hand side. Okay, now ready. I am sure, no hesitate to do the factorization. The trinomial is super easy. Is x minus, because this sign is this sign, square root this guy get 5. You can leave it like that if you want. We'll put in this. If I were to 2.5, then you put 4 parenthesis x minus 2.5. It's good. Either way, it's good. Let me manipulate the right hand side. The right hand side, well, you're subtracting. You subtract the 57 minus 25, 32. No? Y minus 32. And one more time, I see is there common factor is 8. So y minus 4. Okay, I finished almost, because look at that in the standard form. This coefficient is 1 invisible, no? There's no 4 here. Divided by 4 both sides. Now, definitely, you have x minus 5 over 2 or 2.5, the way you prefer. X equal 8 divided by 4 is 2, y minus 4. Cool. And this is my equation, equivalent 100% to the original. It's algebraically the same thing, but now you can see more clear who is H, who is K, and who is P. Okay, so now H is solved with 5 over 2 or 2.5, either way. Okay, H, so the vertex of this parabola is at the point 2.5 or 5 over 2 positive, comma 4. Comma 4 or comma negative 4? Comma 4. Comma 4. Comma 4. And 2p no. 2 is equal to 4p. So these 2 is equal to 4p, because the coefficients inside that. Therefore, p is 1/2. Okay, so with this information, wait. So p is positive. It's a small number, but it's positive. That means we are doing a parabola. Okay, this parabola, okay, roughly sketch. The vertex is 2.5, 4, 2.5, 4, 2.5, 1, 2, 3, and the middle, and between 2 and 3, 2.5, 4. 1, 2, 3, 4, and no, 4, stop at 4. 2.5, 4 is my vertex, and of course this parabola open, off, because P is positive. A little bit narrow, remember, the focal distance, the diameter here passing through the focus, depending on P, no? Actually, that distance is for P, and for P is 2. For P is 2. Therefore, P is 1/2. No? So it's 2P in one direction, 2P in one direction. Actually, 1 in one direction and 1 in another direction. No? At this point would be the point 3, something, because P is 1/2. 3, 4.5, I guess so, no? Yeah. And another direction is 1.5 because it's 2 minus 1. Minus 1 is minus 1. No minus 1. Is 0.5. Okay, let's see. Now the detail numerically we are seeing the software and decimal. The most important in the piece of paper was the conversion from general to standard. It's a general form. Remember, general form is when you have equal 0 on the right hand side. How general you organize and send all the degree 2, degree 1, and alphabetical. But this is a standard. It's a beauty. Okay, let's move on to the decimals. The application que remember I sent to you for the let me try to share the screen. Boom. Boom. You see that? Yes or no? Yes. Okay, now thank you. Okay, this is the parabola. Look at that. Boom. 4x squared minus 20x minus 8y plus 57 equals 0. Okay. Now, in our parabola, P is 1/2. P is 1/2. Okay, you put here 1/2 or 0.5. What about H and K? Well, H is 2.5. Positive, of course. You put it here. H is 2.5. 2.5. And K is 4. Okay, good. And you got categorize like the vertical parabola, no? Like so. Boom. And we have here the picture in detail. This is the vertex. The vertex is 2.5, 4 exactly we predict. The focal is P distant up, because remember the focal is inside the parabola. And how you find the coordinate? The same H, que 2.5, pero comma 4.5. Why 4.5? Because the distance is P, que P is 0.5, and 4 plus 0.5, 4.5. And this in green color is the focal diameter segment, ¿no? Que es 2P en both directions, ¿no? Entonces 2P es, si P es 1/2, multiplication by 2 es 1, entonces therefore this point is 3.5, because it's 2.5 plus 1, and 2.5 minus 1 is 1.5. Okay, cool. Directrix is this line, que es y equals something, y equals 3.5, y 3.5, because the P distant down. See, this is 4 minus 0.5, 3.5. Okay. And the axial symmetry is a vertical line coincident with the H value, que es 2.5, is the line x equal to 2.5. End the story. Any question? No problem. Emily T say no problem. Okay. Okay, entonces you no problema with the parabola, no? Entonces let's move on to the hyperbola. Let me explain it here. Hyperbola. Now, hyperbola is a little bit different because hyperbola first of all have two branches. Let me explain the theoretical part for the hyperbola. Hyperbola. In the hyperbola, we have two branches. So one possibility is to have one hyperbola like that or one hyperbola like that. Huh. How you identify the hyperbola? Well, I call this a horizontal hyperbola. Huh? Horizontal. Horizontal. And this is vertical. Actually, it's the name I call my student. No, however, in the book, no. In the book, the classification is according to the transversal axis. Versal axis. And what is that? Well, this is the axis like that. Look, let me show you in detail. This is the axis like that. Boom, 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 transversal axis. And in this case, no. The transversal axis is like that. When the transversal axis is parallel or coincident, in this case coincident, with the x-axis, and horizontal. When the transversal axis is parallel or coincident with the y-axis, so it's vertical. And how do you know that? Well, according to the formula, look. The formula is a little bit weird. Let me explain. The formula, for example, for the one horizontal hyperbola is x squared over a squared minus y squared over b squared equal 1. Of course, this is a standard form. Okay, entonces now you need to be careful because A and B is different meaning of the elixir. You remember very well, I suppose. In elixir A is a big value. No. And the hyperbola, no. Look, let me show you the formula for the vertical. The formula for the vertical is y squared over a squared minus x squared over b squared equal 1. I don't care who is the bigger. No, it's no idea for the classification. When the positive part of the hyperbola is associated with the x, that's the horizontal hyperbola. And see, the positive part of the hyperbola is associated with the y is vertical. And always the coefficient in the positive part is a, always. And in the negative part is b. End the story. Okay? Of course, we have another collection of the formula in which the center is not necessarily in 0, 0. No. It's in h, k. And the formula is very similar. It's x minus h. Remember, the letter h is associated with the x. And the letter minus, no plus is elixir minus a hyperbola. Y minus k squared over b squared equal. You see the idea? The idea is center is 0, 0. Now center is h, k. Likewise, in the vertical hyperbola, we have y minus k squared over a squared minus x minus h squared over b squared equal. Okay, the most important detail is the positive guy. The positive hyperbola have one positive and one negative. If the positive guy is associated with the x, it's horizontal. And the famous transversal axis is or parallel or coincident with the x-axis. In the vertical, the positive guy is y, and the axis, the transversal axis, is parallel or coincident with the y-axis. That's it, almost. One more detail, important detail. What about B? What is the participation of B, guys? You have focus? Yes, of course, you have focus, you have vertex, and you have more than this. Look, let me try to do one sketch of this again. Okay. We have suppose hypothetical, que es horizontal, to make easy the problem. It doesn't matter. It's in both cases in the example. This point, and this point is the vertex. Okay, B1, B2, vertex. Okay, the vertex always lie in the transversals. And this distance is A. And this distance is A from the center. This is the center. In this example, I put like a 0,0, but not always is 0,0. Maybe it's H, K, and you translate the hyperbola into the point. Okay, cool. And what about B? Who is B? Well, B. To see B, you are doing now here. One thing is called a reference rectangle. What is that? Well, this is a rectangle that we use. Not necessary to do in detail, but important is okay, this side is AA and the other side is BB. B and B. And this is B in both directions, no? B up, down in this case. And we have the famous rectangular reference. In the application that I have in this, immediately when you select, he's doing the rectangular reference rectangle. And now, if you connecting the corner of this reference rectangle and the center, you have one dotted line here, another dotted line here, It's because any hyperbola have two asymptote. Of course, line asymptote. And the formula of the equation of this asymptote is, in this case, y is equal b over ax plus or minus, because b over a represents the slope of this line. Look at this segment b, this segment a, the slope is b over a, and we have two asymptotes. One can have a slope positive, or another can have a slope negative, no? And this is the formula for the asymptote, que is important in any problem. We need to determine the asymptote because it's part of the game. That's it. No, we have forces. Let me try to use the C, the famous C. In this case, remember, in the elixir, you have the parameter ABC. In the elixir, we have the famous ABC. Yeah, I know it very well. In the elixir, A is the biggest. In the hyperbola, no. In the hyperbola, the biggest C. So C is equal to A squared plus B squared. Therefore, C alone is a square root A squared plus B squared. And also C is the focal distance, exactly the same idea, focal distance. But the focal distance is measured from the center, this distance. Let me try to use in green color. So we have force C1, this distance I put in green color is C, and the distance is also C in another direction. Okay? And that's it? No. We have more detail. Because remember, I analyzed the problem for hyperbola horizontal. And what about hyperbola vertical? It's similar, but I need to explain it. Look, suppose one hyperbola can look like that. Vertical. How do you know it's vertical? Because the formula is y squared over a squared minus x squared over b squared equal. Remember, in this case is x squared over a squared minus y squared over b squared equal. And the positive part indicates us que es horizontal or no? It's vertical because the positive part is associated with the y. And similar, we have vertex b1, b2. I call arbitrary who is b1 and who is b2. And this distance again is a. And we have the famous reference rectangle. But this distance is b. This distance is b. This distance is b. Therefore, in both cases, the reference rectangle is rectangle like that, and this distance is 2a, sorry, and it's 2b. In this case, no. In this case, is reference rectangle. This distance is a. Now let me see a and b. Wait. I make a mistake. No, I make a mistake. This is 2a, and this is 2b. In this case, no. In this case, this is 2a here. Look vertical, and this is 2b. Okay. And again, our asymptote look like that. It's very, very interesting. I want to show you this one. When you put equation, the hyperbola approach it to the asymptote, but never touch it. It's obvious, no? You know the slang asymptote. Okay, now the focus is located here at this distance. Suppose green color. Okay, always inside the hyperbola, not outside. And this distance is c, and we compute using the same formula. And the equation for the hyperbola, for the asymptote, sorry, is y is equal plus or minus, similar to this, but now it's a over b. Because in our line, this is a distance and this is b distance. The slope, as always happen, is the ratio between right and wrong. Right says a, wrong is b. Completely opposite, so it's completely different to the horizontal. Okay, I want to see what the last thing, theoretical. And the scenario, que the center is not located in the 0, 0. No, it's located at the one arbitrary point h, k, center now h, k. Well, the idea is similar. The idea is similar, but you plot first the center. So now, suppose that you determine the transversal axis vertical. Okay, cool. You move a over, a downward, and you determine b1, b2 as the vertex, right? And you moving from the center, b to the right and to the left, and you are doing our reference rectangle one more time. You connect the corner by the rule, the other line, and you have the asymptote. And important. The focus lies always in the transversal axis. This is our transversal axis here. Here, over there. In this case, the transversal axis is like that. And the equation of the asymptote is similar, except that we have at the point h, k. Entonces we using, guys, the formula that you very well know, que es point slope formula. Look, y minus y1 is equal m x minus s1. Do you remember this in intermediate algebra or in high school? Entonces, y minus k, because you take the point like a center, is equal plus or minus b over a x, parentheses, sorry, x minus h. Okay, and the scenario, the h and k is 0, are using this easier equation. Another no. Here is similar, is y minus k is equal plus or minus a over b, parentheses, x minus h. Okay, cool. Let's practice. I bring, as always, 4 examples. 4. For example, 4. No, 5. Wow. No, for example. For example of each. Okay, cool. Do you follow me? You have any question? Let's practice. Now let's practice. No more blah blah blah. No more theoretical part. Let's practice. Let's practice. Example 1, hyperbola. Okay, we have x squared over 4 minus y squared over 9 equal. Cool. My first question is, where is located the center of this hyperbola? Help me, guy. Help me, guy. I'm boring to do this. Where is located the center of this hyperbola? Well, identification of hyperbola because it's minus. Where is located the center? Come on, participate with the chat. So the point, something, comma something. Nobody know? No. Do you see or not? Are you sleeping or you connected? 0, NAF say 0, professor, because I don't see any H, I don't see any K. Okay, cool. My next question is, this is vertical or horizontal? So let me reformulate the question. Our famous transversal axis is like that, boom, 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 or like that, boom, 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 boom. This is horizontal, this is vertical. How do you know that? What is the clue? Okay, it's vertical. Emily T is vertical. No, Emily T, because when you take a look, the positive guy. This is confusing. This is important that you make a mistake because in the leaks, no. Okay, I understand. I appreciate so much that you make a mistake because I want to take advantage of this moment to explain. Okay, the orientation of the transversal depends who is positive and who is negative. I see clear like a water that the positive term in this equation corresponding with the x. That means our no, who is the bigger? No, and the leak say yes, I agree with you. But in the hyperbola is another completely different criteria. Okay? So the conclusion, we are in front. No problem. I understand. We are in front one horizontal. Okay, and what is A and what is B? And what is A and what is B? Another confusing part. And the hyperbolic is different to the ellipse. What is A and what is B? Well, who is A squared and who is B squared? After you find the square root both sides, and you tell me what is A and what is B. 4 and 9. Bueno, I suppose Sergio. Sergio say 4 and 9. So A4 or A squared. Sorry. A4 and B squared is 9. Therefore, A is 2 and B is 3. Okay, I repeat one more time, guys. No, A is not the biggest. This idea is clear, pero en el X. Yeah, no. A is the parameter associated with the positive part. It's A squared 4 and B squared 9. Okay. Now I take advantage in compute C. Well, C, not necessarily square. If you know C alone, que es the square root, A squared plus B squared. This is the new formula for the hyperbola. No? It looks like similar, but no, actually it's not similar. It's a square root 4 plus 9, 13. And square root 13 in decimal approximation is 3.606. Remember, decimal approximate 3 decimal places. Okay, what more information we need? We need we need the vertex. Okay, roughly sketch. I know. Okay, our hyperbola somehow look like that because the transverse axis is in this case coincident with the x-axis, and this distance is 2 in this example. And this vertex 1 is located at the point 2,0, and likewise in the other direction negative 2,0. No problem, I understand that. Okay, however, my reference rectangle is a rectangle like that. Okay, this sketch is not good. You see now this. And this distance is 2, but this distance is 3. This is the asymptote. Look like that. Not good, the sketch. Very bad, very bad. My sketch is horrible. Like this, something wrong. But okay, I don't care this. Well, let me try to do my best. Hello. I have a rule, and the rule now working. Another day the rule doesn't work. The problem is that this software periodically is updated. So I see different features. Some feature I don't like, some feature I like. Suppose this is the x-axis. And suppose 90 degree. Is the y-axis. Let me try to do completely differently. I know. Okay, the vertex is located 1, 2. 1, 2. That point is 2,0. This point is minus 2,0. So I write here down. Vertex 1, 2,0. Semicolon. Vertex 2, negative 2,0. And from this, our famous rectangular or reference rectangle, okay, 3, the other segment, no? Entonces 1, 2, 3. 1, 2, 3. I suppose that this is a point. It's a one corner of the reference rectangle. 1, 2, 3 down. Another corner. Another corner. And another corner. We want to determine this point is okay, but no important. Important is the asymptote. It looks like that. This is the order to do by hand. But I forgot the rule. I need to use the rule here. Okay, ready. Using the red color, my hyperbola approximately like that, and approach it, but never touch the asymptote. It's a one right branch, and the left is something. Just in case I do my best. However, the sketch is not super good because do long like symmetric. Look like this actually is symmetric. Okay, now finally, what is the equation for the asymptote? The asymptote 1 and the asymptote 2. No, actually you copy both. This is y equal plus and minus b over a can be 3 over 2, 3/2. Yes, end the story. No, in the story, no. And what about Fossey? The Fossey is that distance. Here, approximately, this distance is 3.605. So this point is 3.606,0, and this is a point minus 3.606,0. Now it's finished. No more complication. Just in case, I want to show you, I want to doubly checking in the software that we have available for analysis of the Conic section. Okay, let's go to the decimals. Okay. Okay. This is a previous example. No. Previous one. Is Hyperbola. Now. Hyperbola example 1. Wow, look at that. X squared over 4 minus y squared over 1. I do the graph of this. Wow. 2 branch. And the vertex is 2. At least I see that. Okay, now I'm moving on to this slider. Ahí they got A is 2. Nice. And B is 3. Okay, much better typing here. And of course H and K both are 0. 0,0 is the center of this logical according to this graph. And what kind? We have the classification is horizontal hyperbola, right? Because the transverse axis on the x-axis. Horizontal. No, but no parabola. Hyperbola. Boom! And you see clear now. Look. This is the center, 0, 0. This is the vertex, 2,0 minus 2,0. This is the foci, 3,60 something and 3.0 something. I changed something, not good. I changed something. I changed the point. Okay, let me refresh this. No, I make a mistake. Well, I don't save this. Okay, no problem. This is 3.606 because I moved the point. Now look. I fixed it. And the asymptote is this line, and you see how the branch of the hyperbola look when approach to infinity. The curve approach but never touch. It's a classical asymptote. Cool. Example 1, hyperbola. Any question? Do you understand? Okay, super. Let's move on to the second example. Always I complicate a little bit more, a little bit more. Okay, let me share the screen switching to the screen or window. Okay, this is the whiteboard. Erase. We have example 2. In example 2, you have different situation. We have 16 y squared minus 9 x squared equal 144. It's obvious that this equation is not already expressed in a standard. No. To the right hand side is 144. Entonces, okay, I need to express it. Entonces, you divide by 144 everything. It's a classic, guys. In the Conic section, right hand side must be 1. No, all in Ellipse and Hyperbola. And you divide 144 divided by 16 is 9. So y squared over 9 minus 144 divided by 9 is 16. You go. Nice. I like that. This is a standard. Nice. Elegant. Entonces now, what kind of the hyperbola we have? We have horizontal or vertical. We have like that or like that. It's a horizontal. It's a vertical. Vertical. Sergio Medina dice it's vertical. Perfect. And the reason is clear because the positive part is associated with the y. Therefore, the transversal axis is like that, and the y coincident or parallel, either way. Okay, cool. I categorize we are in front of the vertical hyperbola. And what about A and what about B? Who is A squared? Who is B squared? Look at the equation. Who is A? Who is B? Or A squared? Doesn't matter, because to find the A and B is too easy. Find the square root, and that's it. Who is A? Who is B? Come on, help me. Help me. You need to practice a little bit that part. Do you follow me? You understand or no? The majority of you understand or no? Nobody? Wow. Why not? Are you tired? A ver. A3, B4. Okay, cool. So this is 9 because this is 9, is the positive part, and this is 16. Therefore, A is square root is 3, and B is square root is 4. Cool. Okay, so let me try to do at least the rough sketch how I suppose can look like our hyperbola x and y. For sure, I know this is vertical, therefore the transversal axis is here, or at least parallel. No? Okay, therefore my hyperbola open in that direction. So you put 3 here, 3. This is center, 0, 0. It's obvious, no? No H, no K. 1, 2, 3 is the first vertex. This distance is A, that distance is A. And down, exactly the same, negative 3. The vertex 1 is located at the point 0,3, semicolon, and vertex 2 is located 0,1. This distance was A in the transversal axis, and B, que 4, is in the other axis que es perpendicular, ¿no? To the transversal, que es 4. So it's 1, 2, 3, 4, 1, 2, 3, 4. Pero I don't care too much to do the rectangular reference. You put 4 here, this corner, this corner, this corner, this corner, and we connect this and this, the dotted line. At least I know the position for the accent. And our hyperbola passing through this point, and open in this direction, and this direction, and this direction. Okay? The only thing I need to complete is determine C. C, remember, is square root A squared plus B squared is square root 9 plus 16, que is 25, and square root 25, 5. Okay, cool, it's easy, no irrational number, no, it's nice. So my focus is located on transversal axis, and the distance focal is 5. 1, 2, 3, 4, and 5. Here is the focus. Focus 1, focus 1, and focus 2 is 1, 2, 5. So the focus is located focus 1 and 0,5, and focus 2, 0,5. And one more we need to complete the job. Well, the equation of the acento, que is y equal plus or minus, because h and k is 0, center is 0, this is the center, 0,0, nice. Pero in this case, vertical. This is vertical, no, it's B over A, it's A over B. X. In our specific example, A is 3 and B is 4. 3 over 4x is the equation of the couple of this. Done. Let's double checking this information that we computed by hand. And we are doing the roughly sketch by hand to the accuracy sketch using decimals. Okay, cool. Share the screen. Do you see the decimals? Let me delete that part. Let me delete that part. And we go to example 2. Example 2 is, look, I copy exactly the same is given in the problem. 16y squared minus 9x squared equal 144. I don't do any algebra. The algebra I am doing in the piece of paper. The product. Bam. What I was expecting is a vertical hyperbola. Now I discover also the A3. Look, I check the value here. B and B is 4. It happens H and K is cool. And you classify like it, vertical hyperbola, no? Vertical hyperbola. Oh, look at that. Let me understand this. Look, center, 0, 0. Vertex, 0,3, 0, minus. Foci, 0,5, 0, negative. And this is the famous corner for the reference rectangle that you connected by the line, the two axes. And by the way, the transversal axis lie on the y-axis. This dotted line represents the transversal axis. No problem? Okay. We have 2 more examples. I want to complicate more this because now we have translation. These 2 first example is easy because we have the center is located at the origin, 0,0. Nice. However, no, and this example is more complicated. Number 3 and number 4. Okay, number 3 now. Example 3, hyperbola. Okay, we have parenthesis x minus 2 a squared over 9 minus y minus 3 squared equal 1. Oh, nice. I appreciate so much. In this example, they give me in standard form. How do you know standard form is the right hand side 1? Must be 1. Nice. And you factorization, no completed square arts. Piece, okay. However, what about center? Who helped me with the center of this hyperbola? Who helped me with the center of this hyperbola? Where is located the center of this hyperbola? Who helped me? No, 2,3. O sea, 2,3. 2,3. In other words, it's like H is 2 and K is 2. And this is the same sign, one of the same, no, the opposite sign. Remember, you have opposite sign. In the equation, when it's negative, the point is positive. And when in the equation, when there's positive and the point is negative, do you know that? This is classic. Okay, this is the center, cool. And what about A and K? A and B, sorry. Who is A squared? And B is, who is B squared? And please, classification, this kind of hyperbola, vertical or horizontal? This is horizontal or is vertical? Okay, let me answer first that question. A horizontal, yes, you're right. because the positive bar is associated with X. Super easy to see. Cool. And what about A and B? Who is A? Who is B? Okay, I don't see very well. I don't understand very well. Who is A? Or A square. Who is A square? A square 9. Therefore, A alone is 3. And B is missing that bar. Entonces ahí supone que es 1. And the square root 1 is 1. Cool. Little by little, I take information about the equation. Number 1, center. Number 2, what kind of hyperbola? Horizontal or vertical? In our case, horizontal. A squared is A. Remember, A is associated with the positive bar always. And B is the negative. Okay, one more information we need. We need C. C is the square root. A squared plus B squared. In our example, A squared is 9. B squared is 1. Is radical 10. Radical 10 is irrational number again. And this is approximately 3.162. Okay, cool. Therefore, let me try to do my best. By hand is a little bit complicated. And when the number is irrational, it's more crazy. But I try, at least I try. Some problem, no. But in this example, maybe yes. Okay. First of all, you plot the center. The center of this hyperbola is located at the point 2, 3. 1, 2. 1, 2, 3. This is the center. What about the vertex? Well, the vertex is located A this time. Remember, this hyperbola look like that. This is the center. The center is this point, and this distance is A. Okay, A is 3. Okay, from this point you move in 3 units. 1, 2, and 3. This point would be 5,3. Where come from this 5? 2 plus 3. In the other direction, 1, 2, and 3. I suppose that this point is the point -1, 3. And what comes from -1? 2 minus 3 is -1. Okay, I like that. Entonces, the vertex is, is 5,3 and -1,3. Okay, cool. One more thing to do approximately, using our best skill by hand. The asymptote, FB. Actually FB. And B1. Oh, so we have one corner here of the reference, another corner here, another corner here, another corner here. And this distance is 1, 1, 1, 1. If you want to plot the point, you can, but not necessary. Now we're connecting this by the line. This is the asymptote. And finally, a little bit roughly, this is the vertex, open in this direction, approach it, but never touch. I did wrong here. Approach it. What is the last step? Well, the last step is the fuzzy, but the fuzzy is a little bit weird. This number is weird. But I know it's located here, approximately. One distance, focal distance is, this distance is 3.162, no? And you add in, entonces 2 plus 3.5.162. The fuzzy is located then. at the point 5.1C2, comma 3, no? Because it's the same Y value of the center. And the opposite direction of subtraction is subtracting 5. Subtracting 5, no. Subtracting this number, 3 point something, is negative 1.162. Basically, is 2 minus 3.162 and 2 plus 3.16. But don't worry too much for this, because the application of decimal computed by yourself, by itself, is not. Okay, let's do it. I forgot the equation of the asymptote. I forgot. Okay, now the equation is, remember, y minus k. And who is k? K is, this is h, and it's a k. It's very. Did I make a mistake or not? H is 2. I make a mistake in paper. Y minus 3 at that point, this point, is equal plus or minus b over a, but b is 1/3. 1 over 3 is the slope. You see, it gets a little bit, not too much inclination of the slope. X minus h. Okay, let me fix in my paper. This is 3, and this is 2. I did well, guys. Yeah, I did well. Okay, ready to move into the decimals application. Here. Okay, good. In this case, remove that. I want to go to the example 3. Yeah. This is example 3, exactly the same. No, I copied wrong. I copied in the paper I put minus, no? And I fix it. Just example, I type in here minus. Okay, nice. Yeah, I put that. Okay, I like that. This is the center, maybe 2,3. Makes sense here. Okay, remember fixing your copy. Now you check it. Okay, now we have the A3 and B4. And H is 2. And K is 3. No negative 3 is possible. Okay, and we classify like a horizontal. Oh, wow, too many information. Okay. We have center 2,3. We have vertex 5,3, and this point is 1,3. This is the corner of the, it's not important. And the foci, you know, is very close. The foci is in blue color, no? Very close to the vertex. 5 point something and negative 1 point something. Okay. And you have a super detailed sketch. Too much detail. It's enough detail. Guys, everyone follow me? Hyperbola is complicated or easy? It's easy. Okay, it's easy. Okay, let's move on to the last example of hyperbola. Last example of hyperbola. Example 4. Example 4. Always is the last complicated, no? Okay, you need to complete the square or something. 11x squared minus 2y squared plus 66x minus 4y plus 75 equals. So as expressed in general form, I need to modify in order to express it like standard. So when you manipulate this using complete square technique, well, finally we get, I don't know. No, I know. Okay, we get something like that. You need to get y minus h squared divided by a squared minus y minus k squared over b squared equal. And how do you know this in this way and no opposite? Because x is positive and y is negative. That means our transversal axis, so it's basically, this is the horizontal hyperbola, no vertical, because x is positive, y is negative. Okay, let's manipulate algebraically. You find one expression similar to this, but algebraically equivalent 100% to the original. I only modify, I never change, modify. Okay, so now you grouping the x part. The x part is this and this. And I can see, wow, I take advantage. Okay, 11 is a greater common factor of 11, and we have x squared plus 6. X. Okay, I forgot mentally the y part and the other number for 75. Do not exist in my mind. Only I focus on 11x squared and 66. I need to complete the square. Okay, now I'm focusing on the y part. I factor out. I factor out what? I factor out -2, I guess so. -2 out. We have y squared plus 2y. Plus 2y. Because I factor out the negative and 2 and stay inside the parenthesis 2y. If you want to verify that we're doing well or no, you are doing backward. So your multiplication, this time this is -2y, exactly like that. And multiplication this and this is -2 and +2 is -4. Cool. Okay. No problem, I understand. Plus. Another magic number can complete the square. And in the right hand side, I move 75 negative and 2 boxes. And these 2 boxes contain 2 numbers that allow me to keep the equilibrium of the equation. Because when you find that number, you take 6 divided by 2 squared. A square. I put 3 because I am dividing mentally. Okay, this is 6 divided by 2 is 3. 3 squared is 9. This 9 I put it here. 9. Okay, likewise here. You take 2 divided by 2 is 1. Square of 1. And this one I put here. You follow me? What? You put it here. Alright, yes. You follow. Okay, not bad. I understand. However, what number you put in the right hand side? Actually, is 9 multiplied by 11 gets 99. Positive, no? And 1 multiplied by -2 is -2. Something like that. This is the organization. Okay. Now, the beauty part. You put 11 and your factorization, I guarantee you that this perfect square trinomial plus 3 square, welcome from 3 is square root 9, welcome from x is square root x squared, minus 2 times y plus, it's plus because this sign is positive. And the sign, and the second sign is always positive. The artificial number that you put to complete the square is always positive. And the other may be changed, positive or negative, and that determines automatically this sign. See, this is positive, this is positive, the first sign. Okay? Now this is plus 1 squared. In the right hand side, wow, we have, well, 75 and 2 is negative together is 77. Pero negative. Plus 99 is 22, no? I guess so. 22. Okay, cool. Little by little, you simplification our equation. Now, to be ready in standard, we need the right hand side 1. 1, not 22. So you divide by 22. Divided by 22. Divided by 22. And 22 divided by 11 is 2. Put 2, of course, in the denominator. Minus. And you divide 22 divided by 2 is 11. Y plus 1 squared over 11 equal 1. Wow, fantastic. And this is my nice equation in standard. Equivalent 100% to the horrible original equation. But I can see everything clear now. Oh, no, super clear, but because the number is weird, 11 too. Wow. Okay, the center is obvious. Que es located at the point minus 3, negative 1. Be careful, guys. Remember, the center is the same value h and k, but opposite side. And the reason is clear, because these 3 come from, for the negative 3, can you plug it in here, and negative 3 and another negative can bring me the equation, automatically is positive. And the shortcut to do fast is opposite side, in the equation and the point. Okay. And what about a and k and b? When I solve the a square 2. Wow. And a alone is radical 2. And radical 2 is a irrational number, it's approximately 1.414. And b squared is 11. Therefore, b alone is square root 11. The square root 11 you put in the calculator is 3 point something, 3.317. This is a super weird number, but don't worry for this. You put in decimals. And you compute, for example, c squared. I don't put this in my calculator, in my paper. I don't know why. C alone. No c squared. Is square root 2 is a squared plus b squared is 11. 13, no? And 13, let me copy here, square root 13, square root 13, 1, 3, the value is 3.6. I did before this. So C is square root 13, it's approximately 3.605. Ready to see that. And what about the equation for the asymptote? I don't forget this part. The equation of the asymptote is, I remember that we are working with the horizontal hyperbola, right? Yeah. And the equation is, in general, no, is y minus k is equal plus and minus b over a x minus h. In particular, this example is y minus k, k is, this is h, and this is k is negative 1, double minus become positive. plus and minus, and B and A is a weird number. It's radical 2, radical 11, sorry, divided by radical 2. Now you put together if you want, but no, leave it like that. X minus H que 3. Okay, the equation for the asymptote in this problem is y plus 1 equal plus or minus radical 11 divided by radical 2. If you put together, if you want radical 11 or 2, including inside only one radical, it's okay, it's the same. Okay. This is the equation. Okay, let's do it now to the decimal to checking this idea. Okay, you know, it's horrible because the decimal is very, very complicated. Let me try. Okay. Okay, I suppose you see this one now. Let me delete everything. Delete it. This is example 4. That's the last one. Is 11x squared minus 2y squared plus 66x minus 4y plus 75x squared. Do the graph of this. It's a hyperbola. It's solving horizontal. Okay. Now the parameter for this hyperbola is a little bit weird because A is radical 2. So now I need to use the decimal keyboard to type in that. You can type it in decimal, but no, my recommendation is much better you typing radical 2. Square root 2. Boom. It's more accuracy, we have more decimal places. What about B? B is radical 11, no? Radical 11. Okay. And what about H and K? Well, H is -3 and K is -1. Okay, cool. Now ready. The classification is the horizontal, no? Horizontal hyperbola. We see we are number, but it's normal. This is the center, the point -3,-1. This is the vertex here. This is the focus, and this is the asymptote. And the story. Good. Any question about Conic section? I promise in the review package. No question. And the review package, we move it over again. This solving the most specific example you need to know for the test. Okay, so we spend the rest of the time we have. There's not too much, but I try to take advantage to start new section. It's called a super easy, a sequence. Sequence in arithmetic, I mean, in algebra. Okay, let me explain the theoretical part of the sequence, and after we see applications. Okay. What's the idea? A function we can interpret a sequence you can interpret like a function. Function whose domain is a natural number. Who is the natural number? This is a fancy M. Is 1, 2, 3, 4, so only positive, starting 1 and continue forever, no? And connecting the range with the order. So fraction, irrational, crazy. And normally these functions have connecting with the formula. So this is explicit formula. There are two different ways I want to explain the sequence. The first one is the easier, is explicit formula. An explicit formula normally is called A sub n, because n is the index 1, 2, 3, 4, 5. Suppose one example, elementary, you have one sequence whose explicit formula is 2/3 raised to the n power, like exponential. And the question is trivial. You see, compute the three first element in this sequence. Like, in other words, you compute A1, you compute A2, and you compute A3. It's just plug it in. It's 2/3 raised to the 1 power. It's 2/3. The second is 2/3. I don't see the word. Ow. Because I don't share. I forgot to share. Now? Okay. Now, forget about this. I start at the beginning. So the name of this chapter is sequence. What is that? Sequence you can interpret it like a function. Function can state the connection, association, and between natural numbers. So this fancy M represents the natural number. 1, 2, 3, 4, continue to infinity forever. No? This 3 point is to continue in the same pattern one by one, and you associate with the own one real number. So the answer maybe is a fraction or irrational real number. Now, in this part, we have two possibilities to express the sequence. The first one, get it easy, is using explicit formula. Try to remember this name, explicit. This is important. Explicit is you have, for example, a number is called A sub n. A sub n, suppose one hypothetical example is 2/3 raised to the n power. And the classical example is one, try to find the first 3 or 4 or 5 elements in the sequence. Okay, so you compute A1, you compute A2, you compute A3. And A4, the number can ask you the question. So this is easy. You put 2/3 raised to the 1 power, because n is 1, and 2/3. Done. A2 is 2/3 raised to the second power. It's 4/9. 2 to the second power is 4, 3 to the second power is 9. And A3 is 2/3 raised to the cubic power. Is 2 to the cubic power is 8, and 3 to the cubic power is 27. Because 3 times 3 times 3, 3 times is 27. That's it. This is the explicit. The majority of the examples we are doing is given the explicit. Just is plugging in. That's it. However, we have another way important to represent the sequences, que es the recursive formula. I want to explain now recursive formula. Sometimes it's not pretty easy. Okay, you guess it what the explicit formula. No. So I bring one example to illustrate this idea. It's the famous Fibonacci sequence. Fibonacci sequence. Fibonacci is the last name of the one famous mathematician in Italy. Can discover this pattern. Okay, look like we are, but actually we can find the formula. Suppose we have one animal. Fibonacci try to study the propagation of the rabbit in one farm. So for example, we have one adult rabbit. Let me try to do my best skill with the rabbit. Look like rabbit or no? Okay, so we have one adult. I want to call big, and the small is the child. A baby rabbit. So now the propagation is approximately, the model Fibonacci generate to study the propagation of the rabbit in the form is one rabbit reproduced in one big, by the way, this is the same of this, and give me a child, it's a little. Okay? And this part is continuous forever, therefore, this is again a big and a little, right? But this no, this is a big, because transform it for the baby rabbit to adult. Okay, I understand this. Now let's continue in the same pattern. A big is transformed like a big and little. The little is transformed like a big, and the big is transformed by big and little. Okay, so now let me try to guess it. We have one rabbit here. We have two rabbits, one small, one big, like that. We have three rabbits in this moment, two big and one little, and we have 1, 2, 3, 4, 5 rabbits. My question is, how many rabbits we have in the next step? And I try to discover the formula to the rabbit in any moment. So this is natural number, n equal 1, n equal 2, n equal 3, n equal 5. Let me continue to understand. After I try to discover the formula. For the big, again, we have big and little, no? Big and little. For the little, you have big. And for the big, you have, again, big and little. And for the big, you have big and little. And for the big, little, sorry, you have a big. Let me count. How many? 1, 2, 3, 4, 5, 6, 7, 8. 8. Okay, no, sorry, this is a sub n. And this is n equal 1. And this is a sub n. And this is n equal 2. This is a sub n and n equal 3. This is perfect coincidence. But this is a sub n and n equal 4, f5. And a sub n is 8 at n equal 5. Because I need to investigate what's going on in 6, 7, and so on to infinity, the formula. This is the challenge. This is a little bit complicated problem. Okay, I discovered, for example, at the beginning for n equal 1, we have 1. For n equal 2, we have 2. Okay, and for n equal 3, we have 3. And these 3 may be, in my imagination, come from 1 plus 2. And these 3 was the result of the adding this and this together. And the next is 5. And this 5 comes from maybe 3 plus 2. So this and this. So you adding the Fibonacci sequence, the pattern, is to get any number of rabbit in any moment. You adding the 2 previous. So this 5 come from of 3 plus 2. And this 8 come from 3 plus 5. It's 8. You want to find next guy 6. You can continue doing this, but it's crazy, no? Entonces now es A plus 5. 13. Razón, n equals 7 is 13 plus, this is 13, plus 8 is 21, and so on. This is Fibonacci sequence. Entonces es super hard discover the explicit formula to identify this sequence. It's super hard. It's impossible. No, it's possible. But it's beyond the expectation of this class. Because you apply mathematical weird method that you don't know to find out. However, it's relatively easy identification. Actually, we did that. Que A sub m is equal to the sum of the two previous. And the sum of the two previous, you can indicate like that. A sub m minus 1, que is before m, plus A sub n minus 2, que is before the close. And this is the recursive formula. Recursive formula, no, we have no explicit. You plug in and magically you get the value. No. You have some connection in between the previous value and the new one that you want to find. This is the difference to the, I promise guys, the teacher can explain to you Cal 2, so calculus 2, go again over this and explain in more detail and more example about the recursive formula, and I guarantee you that you need to use it in your life in calculus. Okay, now I want to introduce to the new super interesting topic inside this sequence, is summation notation. Okay, we study in detail several properties for this. Super useful in calculus. Okay, summation notation. What is that? Suppose you have the sum A1 plus A2 plus A3 plus pero no infinity. No, you ending in 20. It's too long. And we can condense it using this notation. Summation notation. You copy this Greek letter. Let's call it is a Greek letter. Letter TT, L, TT, L, E. Que es call it sigma, capital sigma, because we have lowercase sigma like that in Greek alphabetic, and capital sigma is like that. And you copy capital sigma, you put here the formula, the explicit formula for the sequence que contain this summation, and you put here the limit, and the limit is for n equal 1 is the first guy, for n equal 2 is the last guy, and the rest in the middle away to the same formula, and you condense it two long summation and one short summation using summation notation. Entonces now there are different versions expressed like that. You put here and you put n equal 1, exactly the same, but just 20. No specification n, because before you're supposed to get the same letter, m. Another guy, a little bit, they want to save time. You put from 1 to 20. I don't like this. The most popular is this. Okay. Okay. Entonces now, let's do it, pero in another version. Well, no, another version, no, it's the same. It's supposed to see it in another version. Suppose you have, I give you the summation notation of the one example, and you expand 1 over k. Okay, the letter that we use in the summation notation normally is M, the most popular, K, I, or J. So this is the index variable. Index variable. Okay, help me 1, 2, 3, 4, 5. This is N is very popular. K is super popular, in my opinion. I and K, more or less. So now what's the problem now? The problem is expand. So doing power. I give the contraction, the condensing, the summation notation. No. But I want to expand. So you evaluate from 1 to 5 here in the explicit formula. This is called like S to K. So the first one is 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 5, and if in 5 you stop. So basically the thing we're doing is expanding summation notation. Okay. In this case, 1 over 1 is 1, not necessarily by any fraction. Okay, one more is the last one, and we continue the important property for the summation notation on Wednesday. So now is, for example, I have completely different. We have 1 square plus 2 square plus 3 square plus no infinity is final, but it's too long. 9 square, and you can express it like a summation notation. Okay, so I see okay, the number inside is 1, 2, 3, 4, 5. It's a natural number. I want to call N or want to call K, either way. I prefer K. K is natural number, belong to the natural. And this go from K equal 1 to that. The first one and the last one. That's it. Entonces I propose to stop, because the next is a little bit complicated. I need to explain for the next lecture in detail. Okay, stop here. That's it for the day. Okay. Stop sharing. Do you see my face now or no? Okay. So now, guys, good afternoon, everyone. Wednesday we continue. This chapter 4 is the last one. Okay. Bye. See you soon.